going to be 0, well, I'll write it this way, B L3, L2, excuse me, times the cosine of 90 degrees plus B3 L1 and 2, damn it. Something that looks like this. All of these terms are 0, and what we're basically left with is B inside times whatever this length, this little length L is, will be equal to I enclosed inside this loop, which would be the number of coils enclosed, not the total, times the constant I, all of that divided by mu naught. And if we solve for B inside, it should be related to the number of coils enclosed divided by the length of the segment that I'm looking at. Probably should have gave that an L1 and renumbered everything. Times I. Oh, it's not only mu naught, it's times mu naught, excuse me. Call me on that crap. Right. It's in the numerator, not the denominator. It's not epsilon naught, it's mu, so it's 1 over. Something like this. And this would be the same as saying the total number of coils divided by the total length of the solenoid if they're uniformly spaced. Times mu naught I. So I'm sure that there's not a lot fun about this as you're just sort of watching me go through the mechanics, no doubt about it. But we've seen that expression before, right? That's how you calculate the magnetic field in a slinky, for instance. As long as you have a uniform solenoid, it's the coil density, coil unit length, times the current times this weird constant. So why do we use it? Well, we could use it in a few of these cases, makes our life easier. I've always struggled with why we really need to express it. Biot-Savart is the direct way of always calculating it, kind of like Coulomb's law. However, what's fundamentally important about it, whether it can be appreciated at this level, is not disparaging to you, it's just what the hell does it really mean. What I do want you to take home is that, believe it or not, this expression is one of the 4, if you will, 3, if you call Gauss's law one expression, because one is a 0 result, 3 expressions that define light, much less everything that happens in an electrical circuit. It doesn't get any more fundamental than that. It's like giving you some equation for string theory. You look at it, you go, well, okay, what the hell is that? Okay, there's a couple tensors there, throw in 100 dimensions, and okay, whatever. It's hard to rationalize its value as a calculated term. But the fact that it is so fundamental to nature is highly relevant. And if one were ever to extend their career in the direction of either electromagnetic theory as an electrical engineer in a graduate program, or just a curiosity in nature, or I don't know, maybe even advanced advanced communication systems, right? Anytime you have light wave electromagnetic transmission, radios, not cable signals, but satellite signals, communication, this is fundamental to the relationship between electric current, magnetic fields, and electric fields and charge, and how it all fits together when you do calculations of short and long distance radiation. So there is some stuff there, but you may not see it until much later, but at least sort of appreciate how it kind of fits together. And sometimes it makes life easier in calculations, that's usually not very often. So, when you have to toil with a coil, never fear, just use ampere. And that's about the only time it's an advantage. So, a bit abstract and esoteric there at the end, but it's